Okay, we're going to go over what we covered in class yesterday. So take a look at the notes. So kind of run through them one more time. Over here, what we have is we have some sets of rules for derivatives. So the thing with the f of x plus h, that's like the definition of the derivative. We're going to learn some rules that's going to make it so that we don't have to do that all the time. So if you learn these rules, we move away from the f of x plus h. College Board is typically not going to ask you questions with the f of x plus h in it. We're going to learn these rules. So the first rule we're going to actually learn is called the power rule. And what I'm going to do is I'm just going to kind of run through these definitions and then show you how they work on top. So C is going to represent a constant. So this is what happens when we take the derivative of a constant. The derivative of a constant is 0. And the way you want to think about it is the following. If I were to write the following expression, f of x equals, say, 5. F of x equals 5. That's a horizontal line. And if I were to ask you, what's the slope of a horizontal line, you would say 0. That's because when we take the derivative of a constant, we get f prime of x equal to 0. Okay. And then what we can do is we can actually take the derivative of a function with an x in it. So in this case, if we're taking the derivative of x to the n, so a variable raised to some power, some numeric power, the derivative of that is going to be n times x to the n minus 1. So in other words, we take the exponent, we bring it up front as a coefficient, we drop the current exponent by 1, n to the x minus 1. And if there happens to be a constant in front of it when I do that, we are going to do n times c x to the n minus 1. So again, the n comes up front, gets multiplied times the c, we drop the exponent by 1. So for example here, f of x equals 3x. The derivative of that is going to be that 3x technically has a 1. So we're going to bring the 1 up front, multiply times the 3. 1 times 3 is 3. It's going to be 1 minus 1. It's technically going to be x to the 0, but we know that x to the 0 is just 1. So what that means is the derivative of that function is 3. Or let me put it in a context that you may be familiar with. If I were to ask you what's the slope of this line, from Algebra 1 days, you would say it's a number in front of the x, 3. That's because of these derivative rules. Okay. And then the last rule here is if I take the derivative of a sum or a difference, it's going to be equal to the derivative of the first plus or minus the derivative of the second. So in other words, x squared plus 5. I'm going to take the derivative of x squared. The derivative of x squared, the 2 comes to the front. The x drops by 1, it becomes 2x. The derivative of a constant is 0, so that guy's derivative is 2x. This one right here, f of x is 2x cubed plus x squared. 3 up front, 3 times 2 is 6. We drop it by 1, 6x squared. 2 comes to the front, 2x to the first, 6x squared plus 2x. So that is called the power rule. What that is called, it's called the power rule. It's the first rule that we're going to learn in terms of taking derivatives. There's 3 other ones that we're going to work on. It's going to be quotient, product, and chain rules. And we're going to learn that this helps us kind of do shortcuts on derivatives. So I'm just going to work through a couple quick examples. So the first one I want to show you is 3x squared plus 2x minus 5. If I wanted to take the derivative, I use the power rule on each individual term. So 3x squared becomes 6x plus 2, because that's x to the first, it drops off, and it just becomes the 2, and the derivative of a constant is 0. So the derivative of that function is 6x plus 2. This has got one of these things in it the College Board loves to do. So 4x to the 5th becomes 4 times 5, 20, x to the drop it by 1, 4, plus 2 times 7, 14. Drop the degree, so it becomes x. And here's the trick. Pi cubed, that's constant. Pi is 3.14, 3.14 to the 3rd power, that's constant. The derivative of that is 0, so we don't write anything down. I want to show you that it holds for negatives as well. The only thing you got to be careful of when you do the -1 on this is that when I go to take this derivative, I'm going to kind of be more explicit on this one. It's that lead term -2 times 2 x to the -2 minus 1. That's what it actually is. So when I kind of go to simplify it, -2 times 2 is -4 x. Now here's the thing to be careful about. -2 minus 1 is -3. Think about it on a number line. There's 0, there's -1, there's -2, there's -3. If I'm at -2 and I subtract 1, I'm going backwards. That's -4x to the -3. It also works with fractions. So f prime of x equals that exponent 1/2 goes up front to the x, and it becomes 1/2 minus 1. That's 1/2 x to the -1/2. And we're not going to be doing any simplification. We're not going to worry about negative exponents. We're not going to worry about fractional exponents. We're just going to leave them be. So that's the power rule. Now, again, sometimes what will happen is you'll be forced to rewrite things. The thing to remember is that when I see something like the cube root of x to the 7th, there is a way to write that as a fraction. It's x to the 7 is a numerator over 3. The square root of x can be written as x to the 1/2. So this expression, this function, can be rewritten as x to the 7/3 minus x to the 1/2 minus 2x to the 2/5. And now I can apply the power rule. So y prime, the derivative, is going to be 7/3 x. 7/3 minus 1 is going to be 4/3. Minus 1/2 x to the -1/2. It's basically this one up here. And the last one is going to be minus 2/5 times 2 gives me 4/5. X to the 2/5 minus 1, -3/5. Okay. And last but not least, this guy, we're going to write these as negative exponents. G of x equals x to the -1 plus 4x to the -2. Now, the one thing I want to do right now is we're going to learn another way to do it, but I need to kind of clean this up. The quantity 3x squared is equal to 3 squared x squared, so it's 9x squared. So this guy is really 1 over 9x squared. So I'm going to say this guy is minus 1/9 x to the -2. Notice I left the 9 in the denominator. That 9 has nothing to do with the x, so we're not going to mess with them. Much the same as I go over here, 1/5. X is the only thing that I'm going to change. The only thing I need to change is the variables with the exponents. So now when I go to take the derivative of this, it becomes -1x to the -2 minus 8x to the -3 plus 2/9 x to the -3 minus 1/5 x to the -2. And I'm done with my derivative. Again, the thing you got to be careful with is your negatives and your fractions. So just be careful as you're doing that subtraction by 1. Okay, so that was kind of what we went over. And then I talked about some other ways we got to clean some things up. Number 3, the way I need to clean it up is I need to break it into chunks. I need to make this -16x squared over 2x plus 5x over 2x minus 1 over 2x. I take that denominator and I share it with all the terms in the numerator. I'm allowed to do that in math. And now what I can do is I can simplify. -16 divided by 2 is -8. X squared divided by x is x plus 5 over 2, because the x's divide out to 1, minus 1/2 x to the -1. And now I can actually take the derivative of this. What I can do is it's going to be -8. That's a derivative of a constant, so it's 0 plus 1/2 x to the -2. And that's how we take care of those problems. What I did here at the end is what we actually basically have is putting a number in here means I'm going to take the derivative of it and then substitute a number in. So I'll do this one over here. This one right over here is going to be y equals 1x to the -1/2 plus 4x. So dy dx, which is just another way of saying the derivative, is going to be -1/2 x plus 4. And then when this little bar, x equals 4, it basically means we're just going to substitute 4 in for x. So -1/2 times 4 plus 4. And I'll be honest with you, from a free response perspective, this is where I'm going to stop. But if I wanted to go ahead and finish it off, -1/2 times 4 is -2, -2 plus 4 is 2. So that gives us that. I'm going to go over some calculator stuff next time, and we're going to talk about the idea of continuity and higher order derivatives. So that is what we did on class last time. So if you want to kind of review, you have the answers, and feel free to work the homework. It was the odds.